Okay, so that's 3x. We're distributing through, and so that's going to give me plus 15. And then remember, when you're multiplying, you distribute, or you multiply straight across, so that's 3x plus 15 over 2 times 1, which is 2, equals y. And there's no need to simplify this more. So we have h inverse of x equals 3x plus 15 all over 2. Let's do the final try these. So the final try these, D, is j of x equals 3x minus 2. So first I will rewrite with a y equals, then I'll switch my x with my y. Oh, it was over 6. I apologize, over 6. I will switch my x with my y. I'm going to multiply both sides by 6 to get rid of this division. So 6x equals 3y minus 2. I will add 2 to both sides. I get 6x plus 2 equals 3y, and then divide both sides by 3. And I get that j inverse of x is 6x plus 2 over 3, and you can just leave it as a fraction. All right, let's go ahead and flip over to the next page of the notes. All right, so we're on page 95, and it says the domain, which is the x values of a function, is the range, or the y values, of its inverse. So the domain of the function is the range of the inverse function, and likewise, the range, which is your y values, of a function is the domain of its inverse. So in plain words, the domain and the range of inverse functions will switch. We can see that right here. The domain of the original function, -2, -1, 0, 1, 2, 3, is the range of the inverse function, -2, -1, 0, 1, 2, 3. And the range of the original function, -1, 1, 3, 5, 7, 9, is now the domain of this function. Okay, so it says when finding the inverse of a certain function, such as a quadratic function, the domain may need to be restricted so that both the function and its inverse are still functions. So recall, they said that the inverse has to be a function. Therefore, you must have a function for both. So, example C. It says the function f of x equals x squared plus 5. We want to find the inverse, determine the domain and the range of the inverse of both, the original and the inverse, so that we will have two functions. Okay, and so it says when something is restricted, it is not allowed. In the case of a function, you can restrict the domain so that certain values are not included. The new domain may allow the inverse to be a function. Okay, so the first of all, we have the function f of x equals x squared plus 5. So we're going to find the inverse. So y equals x squared plus 5. We're going to switch x with y. We get x equals y squared plus 5, and we're going to solve for y. So we'll subtract 5 from both sides. We get x minus 5 equals y squared. To undo a square, you square root both sides. Those will reduce out. We're left with y equals, don't forget, when you take the square root, you get plus minus, and then x minus 5. Now, it says the equation y equals plus minus square root x minus 5 does not represent a function. So take only the positive square root. Okay, what would happen is, we haven't graphed something like this yet, but the reason it's not a function is that it will look something like this. That is not a function. Remember, it does not pass that vertical line test. To be a function, the a vertical line can only cross through the graph one time. It's crossing in 2 places. So we cannot have both the positive and the negative root. We only want the positive root, so this part of the root won't exist. Okay, so we're going to use only the positive root. So our inverse function is f inverse of x equals square root x minus 5. Okay. Now it says after we find the inverse, it says find the domain, determine the domain and range of f of x so that both f and f inverse are functions. All right, so we're going to determine what values for f inverse of x will work. So it says the square root function f inverse of x is only defined on the domain of x is greater than 5. All right, I'll explain that. So we have this function, and what happens is to have a real value, we cannot have a negative, so we cannot have a negative under the radical. So we're going to take what's under the radical, which is x minus 5. We're going to say that has to be greater than or equal to 0. We can have a 0 under the radical, but we cannot have a negative. So to find the restrictions on this domain, you're going to, because there's a radical, we're going to set the radical greater than or equal to 0 and solve for x. So I get x has to be greater than or equal to 5. Okay, so this is why it says the square root function is only defined on the domain of x is greater than 5, and the range of f inverse of x is that y has to be greater than or equal to 0. Again, you cannot have a square root. If we had, for example, I'll do it off to the side here. Actually, I'll do it on this paper. If we have this function y equals square root negative x plus 5, not only can you not have so no negatives allowed under the radical, ALL, sorry, allowed under the radical, but also you cannot have a square root equal to a negative value. So that is not going to happen either. So you also cannot have a radical equal a negative. Okay, so therefore they're saying that the range, the y value, must be greater than 0. So the domain of f of x must be restricted to the range of f of inverse of x. So what that means is that the domain, I'm going to do it on a separate paper, the domain of f of x equals x squared plus 5, the domain and the range have to be restricted by these two ideas, that x will have to be greater than or equal to 5, and that y will have to be greater than or equal to 0. So this is the domain of the original, I'm sorry, of the inverse. It is the, I'm sorry, the domain, yes, of the inverse. And this is the range of the inverse. So to find the restrictions for this function, this, right, will become our range. So that means that y will have to be greater than or equal to 5, and this will become our domain. That means that x will have to be greater than or equal to 0. So that is the restriction on this domain. All right. It says, find the inverse of each function, determine the domain and range of f of x so that both f and f inverse are functions. Okay. So let me do that on a separate sheet of paper because I am out of room. So we have for A, f of x equals x squared minus 2. And so to find the inverse, we're going to rewrite it with x and y, switch our x with our y, solve for y, and to do that we will square root both sides, and we get y equals, now remember, we said we'll only take the positive root, so don't worry about plus minus. And then we need to look at the restrictions on this domain. And the restriction on this domain is that we cannot have a negative underneath the radical. So x will have to be larger than -2. Larger than or equal to -2. And for the domain, or sorry, for the range, recall that we cannot have a radical equaling a negative, so that's not allowed. So that means that our y value will have to be greater than or equal to 0. Okay, so my domain and range of my inverse functions, right, are the range and domain of the original. Remember that my domain is going to be my range, and my range is going to be my domain. So my domain is x has to be larger than 0, and my range is that y has to be greater than or equal to -2. All right, we'll do another one. I think this one I'll be able to fit on the paper, so I'll do it here. So we have f of x equals this x plus 3 all squared. So we're going to switch x with y, or sorry, first we'll write it with y, and then we will switch x and y and solve for y. So we're going to square root both sides. A square and a square root, they'll reduce. Y plus 2 is equal to the square root of x. Remember, we're only taking the positive case. I'll subtract 2 from both sides, and I get y is equal to, now you cannot subtract under the radical, so you'll have square root x, and then -2 will be outside the radical. When you write this, please write it the correct way. And finally, if I was writing this in function notation, I would write f inverse of x is the square root of x minus 2. Okay, so to find my domain and range, remember I cannot have a negative underneath the radical. So x will have to be larger than or equal to 0. And I cannot have my y value, right? I cannot have my square root equal to a negative. So to find that, I'm going to actually move my 2 back over. So I have my square root of x minus 2 has to be larger than or equal to 0. And then I'll solve for my radical. I add 2 to both sides. That's what I was saying. I'll be adding 2 to both sides. And I get that the square root of x has to be greater than or equal to 2. So that means that y, right, y has to be greater than or equal to 2. Okay, so my domain of my inverse function is that x has to be greater than or equal to 0, and the range, right, of my function is that y has to be greater than or equal to 2. Okay, so now remember, in your domain and your range of your inverse, your domain is the range of the original and the range is the domain of the original. So that means that my range, right, which is going to be x greater than or equal to 2, and my domain is that y has to be greater than or equal to 0. All right, let's flip it over. And we're going to do a check your understanding. It says the domain of a function is x greater than or equal to 3, and the range of a function is y is less than or equal to -2. What are the domain and range of the inverse function? All right, assuming it exists, explain my answer. All right, so what we know is that the domain in the original function, right, the domain becomes the range of the inverse function, and that the range of the original becomes the domain. Therefore, since my original function has a domain of x is greater than or equal to 3 and a range of y is less than or equal to -2, in my inverse function, my domain will be that x has to be less than or equal to -2, right? These are going to switch. And my range is going to be that y is greater than or equal to 3. All right, guys, I'm not going to do this last example for you. I'm going to allow you to try that on your own. I hope that you took good notes, and I will see you on Tuesday in class.